This question is asking about asymptotes, but this particular function is very well behaved in those terms. To test for horizontal asymptotes specifically, what you do is you look at the limit when x goes to plus infinity of this thing. And the trick to understand what happens here is to divide both the top and the bottom of the fraction by the highest power of x that appears in the denominator. That's in the case x squared, so you divide by x squared, both at the top and at the bottom. So x to the fourth divided by x squared, that's x squared, minus 9x squared, that's minus 9 over x squared. X squared divided by x squared at the bottom there, that's 1. That's what I wanted to happen. That's why I divided by the highest power at the bottom. It's minus 3 over x squared. So this is what's happening. X is getting larger and larger. So this is getting very, very large. But so is this. So 9 divided by something that gets larger and larger, the result gets then smaller and smaller. So that's basically 0. This here is basically 0, or smaller and smaller. And this is getting bigger and bigger. Subtracting 0, subtracting something small, then the answer stays big. So that's something really big, divided by 1, minus, and this is very, very small as well. So it's 3 divided by a very, very large number, because x is like 1,000,000 or something. 1,000,000 squared is even bigger, so 3 over 1,000,000 squared is nothing. So this is just approximately 1, right? That's my point. And also the sign of the top is what matters, because x is squared, so that's positive. So that means the limit is plus infinity. Okay? Same will happen when x goes to minus infinity. So I'll just save a little time and I'll say it's the exact same procedure. So there's no horizontal asymptote. For you to have a horizontal asymptote, that limit will have to be a real number, which would mean, if the limit were L or something, that means that the graph, as x gets bigger, the graph gets closer and closer to that y equals L coordinate. That would be a horizontal asymptote. But we don't have that, so there's no asymptote there. For part B, for vertical asymptotes, we have to find the candidates first before we test them out. And the candidates are the zeros, possible locations for the vertical asymptotes. They come from x squared minus 3 equals 0. So that's x squared equals to 3. So that x equals plus or minus root 3. So we have, those are the x equals a candidates. So either x equals root 3 or x equals minus root 3 are possibilities for the locations of the vertical asymptotes for this function. However, for that to actually happen, for that possibility become a reality, you need one of those limits to be either plus infinity or minus infinity. And that's because we're looking for a situation at minus root 3. This is an asymptote. And that positive root 3, we're looking for a situation either like this, or 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 like this. So the graph approaching the coordinate, the asymptote, when x gets closer and closer to root 3 or minus root 3. So if one of these 4 happens, then x equals minus root 3 is an asymptote. If one of these 4 happens, then x equals positive root 3 is an asymptote. However, if you note that f of x, when x is not 3, or not root 3, positive or negative, f of x can be written using the difference of squares as x squared minus 3, x squared plus 3. And this is the difference of squares, like a plus b times a minus b. On the top there, this is a, this is b. Or you can just FOIL that to see that this is true, right? That this is going to give that back. That allows me to cancel this out because x is not root 3, right? So for both, the limit when x approaches root 3 from the left and from the right of f of x will just be root 3 squared plus 3, which is 6, and also six on the other side. So there's no horizontal asymptote either. Because none of these four possibilities occurs.